About 5 months ago, I decided that a web app I was working on had grown to such a monstrous size that I needed to adopt a framework in order to improve its performance and scalability. I chose Angular and I decided to rewrite the entire program from scratch. During the months that followed, my practices, my thinking evolved as I learned how to use TypeScript and Angular to organize my code into components, services, and modules. Now pause real quick. If you're not sure what those words mean, or maybe you're at a stage where I was about 4 months ago when I had learned what those words meant, but they were still an abstraction that I hadn't really grasped fully, I made a 2-minute video describing Angular for any developer who's familiar with HTML and JavaScript but hasn't yet used a framework. Anyway, it's there if you need it, or in the description. Let's get back. In this video, I've taken my most valuable epiphanies over the last 5 months and condensed them into 5 practical tips that will help you get into the Angular mindset and see how it works in real code. The example that I'm going to be drawing from, the real life example, it's basically a gradebook, except what makes it special is that it's standards-based and mastery-focused. If that's something that interests you, I put a link in the description, but for the purposes of this video, I'm going to explain the relevant details about how the app works as we go along. This is a video about ways of thinking that you can adopt to be more efficient in your Angular project. It is not a coding tutorial. I show code in the examples, but I don't walk through it step by step. If that's something that you're interested in though, here's what you do. Watch the video and let me know in the comments which tips to elaborate on. I kind of feel like tip 5 is my best tip and it's also the most complicated, but confirm my suspicion and at least like the video. That's a great way of sending me a signal. If you don't have the 20 minutes it takes to watch this video all the way through, go ahead and use the links in the description to jump to the beginning of each tip. With that being said, let's go ahead and get started. Number 1. Set up your project with lazy loading modules. Lazy loading means the elements of your app aren't loaded until they're needed. With this tip, as well as every other tip that follows, I'm going to break my explanation down into 2 parts. How should you think, and then what does it look like? So first, how should you think about this? When planning how I wanted my modules loaded, I thought about the user experience. When we land on the page, we have a login screen. So I don't want anything loaded except the login screen, which is really simple, and so it doesn't take a very long time for the page to load. After we log in, we land on a gradebook. Now, of course, this is a sample that I'm using. These are all fake students. It's fake data. You can see up above that there are other features as well. There's a reports tab, a manage tab, student view, conversations, dashboard. Right now, while I'm looking at the gradebook, I don't need any of those other things loaded. If I do want to go over to the report section, for example, I want to load the module and all of the components that are going to appear on the view when I click that button. So that stuff gets loaded and it appears. If I jump back to the mastery book, that stuff is still loaded, so it's going to be quick to access. So to accomplish this, each one of these features is its own module. And because each feature has its own module, there's a really intuitive name for this. It's called a feature module. Now I'm going to show you what this looks like in code. So what I have in this tab is the route file for the app. You can see over here, this is app.routes. And these are all of the route paths. So if we look at one of these routes and the fields that defines the route, we've got the path, and then here I've got a method called canActivate, which is defining some of the fields to describe what happens based on the user's authorization. But the one that's doing all of the lazy loading is this field here, load children. Load children is saying that when we navigate to this route, gradebook, we're going to import the gradebook module. So that's the load the module only when we need it. And then we're going to defer to the module's routes. So here's the gradebook module. You can see that there are all of these directives and components that are declared by the module. One of them is the gradebook component. And when we navigate to the gradebook route, we're going to look at this default route, which will load the gradebook component after the module gets loaded. Number 2, restrict the functions in your components to those that deal with display logic. Keep data manipulation and computations inside services. Here's how to think about this. In order to scale effectively, components and services need to be reusable. Components are really just custom elements. They're like an input or a select. They should be standalone, designed to be used in different contexts for different purposes. They should not be dealing heavily with the data beyond what's necessary to display it. To do so would limit them to a certain context. Instead, all of the data manipulation and computation should be performed inside of the services that are injected into those components. That's the idea, but let me show you in an example. If I wanted to add a new assignment, I would click the plus symbol up in the corner, and that'll open a modal with a form in it. But this form is capable of doing several different types of actions. I can create an assignment, I can create an assessment, I can create an event. And you'll notice when I'm creating an assignment, I'm able to select different standards that are associated with that assignment. However, if I switch over to an event, like a calendar event doesn't have any standards. It's just an event. And so the display for the standard select disappears. We can look at that in code too. So this is my creator component class, and we've got a constructor. These are the services that are injected, assignment editor service. All the accessors here are very simple. Get and set the name, get and set the date, detail. There's not a lot of logic going on here, except when we look at the selected type. When we change the selected type, the method select type gets called. That's down below here. And you can see that it will update the modal title. And then depending on the value of the type, whether it's an event or an announcement, we can set the display standards to false or true. But it's very basic. Let's take a look at an example now to see what I mean when I say data manipulation should be handled in services. I think one of the best examples is what we do with the due date time. So for the actual model that gets saved to the database, we need just a number, the current time in milliseconds. But on the front end, I'm using a bootstrap calendar to select that date, and the argument that's used to populate this calendar, if I'm loading an existing assignment, is ngb date struct. So there needs to be a conversion between that ngb date struct to a number. Over on the side here, I've got the assignment editor service, and you can see here's where I'm doing all of the logic. For the selected assignment, it has to convert to due date time. So whenever the component has to get the date, that date is already formatted in the service. So all of the data in the component is pre-formatted to be displayed, and all of the data manipulation is being performed by the service. Number 3, you can and should extend component classes. Now, the way of thinking about this one goes back to making your components reusable. You will save yourself writing a lot of code if you utilize inheritance. Let me show you an example that solves a common problem for Angular developers. See, in Angular, when a component gets constructed and its life cycle begins, there is a method, ng_onInit, that gets called automatically, hence the name onInit, and you will subscribe to all of your observables in this method. As soon as you navigate away from that view or to another route, that component is going to be destroyed and garbage collection is going to sweep it all up. However, the subscriptions live on. And this can create a memory leak, because if you've got a user that creates a session on your app and they're on it for a while, they're going to have several components that are created and destroyed and created and destroyed, and every single one of the subscriptions made by the sum of all of the components during that session are going to be living indefinitely unless they are explicitly unsubscribed from. So the developer needs to take care of this. And if you do a Google search for handling Angular subscriptions, you're going to find plenty of different solutions for ways of handling it. This happens to be mine. I think it's satisfying, but it's also an excellent example of inheritance. So let's take a look. So here we've got the component class for login component. We've got the declaration up above. Class login component extends unsubscriber. Now, unsubscriber is going to be the focus of this example, but before I show you that, I want to show you the lifestyle hooks for login component. So we've got a constructor. The constructor doesn't do a whole lot. It just injects the services that are needed by this component, which is interesting, by the way, because when Angular is running under the surface of your app, anytime it constructs a component, if that component requires services, it won't inject those services into that component's superclasses. So if the parent component needs a service, you need to inject it into the child component and then pass it up to the parent through calling the super constructor. Anyway, let's look down at ng on init. You can see I've got ng on init, this another subscription equals, and then I've got a subscription over here. Now I want you to look out for how this subscription is handled up in the parent component. I'm going to open that now. Now we're going to take a look at the unsubscriber class, which implements onDestroy. You can see that there's a field, subscription, it's private, and I'm using the subscription constructor here because what I'm going to do is basically make a subscription to subscriptions. Let me show you what I mean. Down here we have that method that I just showed you in the child class. Another subscription, and it's a setter. So when we add another subscription, it calls this subscription add, and then it adds the argument there. But what saves me all the work is what happens on ng on destroy. Whenever a component is destroyed, ng on destroy automatically gets called, and then all of the subscriptions are unsubscribed from simultaneously. So I can handle all of my unsubscriptions by any class that simply extends unsubscriber. I only have to implement ng on destroy once. Number 4, know when to use the input decorator and when to use a service. The rationale behind this one is a little bit more advanced. It took us longer to figure this out. In your app, you have components that display data. There are essentially 2 ways of retrieving data to populate that component. One way is to use the input decorator, and an input decorator is a way of defining properties that can be passed into a component, much like an attribute of an HTML element. Another way a component can retrieve data is through an injected service. Now, you may have a method that is preferable to you, but I would say that in all circumstances, whatever is most intuitive and makes the code most readable given the context is the way that it should be done. However, to get started, I would recommend a rule to help keep things organized and scalable. Consider this. It's possible to have a component inside of a component. And in fact, the components inside the component can have components too. If a component has components inside of it, I'm going to call that a parent component. So the rule is this. If a component is designed to be a parent component, provide all of its data using injected services. If a component is designed to not have any children components, go ahead and use the input decorator to provide data. Now, what is the justification for this rule? To me, the most important reason is that when you use an input decorator to provide data to a parent component, presumably you would pass that data on to its children, also using an input decorator. Therefore, you could potentially have components whose data is sourced up a chain of input decorators. If you need to change something about the data model later, you have to implement those changes in every generation. By comparison, when you use services, you have a direct link. If you change your data model later, you can just change it in the service and it's updated everywhere. Essentially, you're both avoiding a more complicated relationship between all of your components, and you're saving yourself time by having to code less. I'm going to pass on honing in on the example for this tip. Instead, I tried to illustrate as I explained it, but the example in the 5th tip also informs the 4th, so let's go ahead and move to that now. Number 5, use inheritance to simplify. This is really a combination of the 3rd and the 4th tip. In the 3rd tip, I talked about life cycles and inheritance. In the 4th tip, I talked about why services should be preferred as a source of data. But most of the time in Angular, these services are going to be dealing with observables. So you're going to have to be setting up observables, subscribing to them, and unsubscribing to them. You're going to be doing that everywhere, and it can be repetitive. You can use inheritance to simplify and reduce your code dramatically. I'm going to show you how I've done it using the example that you just saw. Back to those modular reports. As you can see, all I have to do up here is change a student, change the class, and all of these components are going to be updated. That's because all of these components are essentially dependent on 2 inputs, a student and a class. So Under the surface, that means somewhere there's a subscription to a student and there's a subscription to a class, and whenever those change, the components being updated. There are going to be a lot of these components. That means there's going to be a lot of subscriptions to class and student. How should I handle that to write as little code as possible? Before I show you my actual code, I want to show you this model. So each of those components in the report is a specific widget, but it has lots of sibling widgets that share a similar function. That function is about where they get their data from. So I'm going to make each one of those widgets be a child of a data widget component, where the role of the data widget component is to build observables based on the requirements of its children. So for children that need a student in a class, the data widget will handle the subscriptions. Now, that data widget can get its input from actually two different sources, which I know kind of contradicts something that I said earlier, but the fact of the matter is there are some situations where using an input was beneficial. So I wanted to have flexibility to take it from either a service or an input. And that's represented in this diagram. So what happens is the data comes from either an input or from my service, which is called DTS, the nickname I call Data Target Service. The child component tells the data widget which observables to watch. That data goes into the data widget, and then the watched observable data gets passed down to the child component. Once the child component receives that data, it has its own service for manipulating that data in order to produce some of the things that you see in this example, like this list of progress alerts, or this bar, or that number. So it sends the raw data that it got from the parent over to its service, and then after that data has been manipulated and is ready to be displayed, it gets passed back down to the specific widget. So that's the idea. Let's take a look at how it's implemented. So what I'm going to look at is the individual widget for the progress alerts. And you can see the progress alerts tells us about things that we need to be aware of, and then it lists the standards where we're having problems. So what does that class look like? That's it. 57 lines of code. What happens? Well, progress alert component extends data widget component. Now, like I said earlier, when Angular constructs these child components, it's not going to automatically inject services into any parent components. So what I have to do is inject them here and pass them up through the super constructor. Then what we do is we set what data we want to track. So for this one, we want to track the class data and the member data. So what's going on inside the parent component? Let's take a quick look at this. Basically, the parent component, data widget component, its job is to create the observables for all of the different things that the children could observe. So I've made this observable map, and currently there's only two things that could be observed, the class data and the member data. You'll recall that in the constructor of the child, we said that the data to track was from the observable map, the class data, and the member data. So that's defined up here. In ng on a net, we look to make sure that some data has been marked to be tracked, and as long as it has, we set up a subscription, and you can see I'm using my unsubscriber class to combine the latest data from the data that's being tracked and call onDataChange. Now, onDataChange is down here, and it needs to be implemented by the child component. So basically what's happening is any updates to the data are being passed back down to the child, and that's what we see happening here. onDataChange, it's taking the class model and the student information, and here is actually using the service that's specific for this widget to convert that data into something meaningful. And again, you can see that the heading, the description, and the list are very simple. Heading, description, list. So all of the heavy lifting is being done in the service. So those are my 5 tips for Angular project setup. I hope they were useful to you. I know that it spanned a whole lot of topics and there was a lot of code that was talked about in this video. If you have any questions, if you'd like to hear me go more into depth about any of the code, please like this video. And if you actually submit a comment more specific, then I can really follow up with something that will really get at what you're interested in. Aside from that, I make weekly videos about innovation really, but right now I'm in a big software development push. So I've been doing a unit on Angular for beginners, and now I'm starting to do some of this more advanced Angular material that I've actually been working as I've been developing my own app. Your feedback is very appreciated. Like and subscribe, and I will see you next time.